Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why parents talk to babies in that song, super clear way? Does it actually help babies learn language better? That's the big question scientists have been asking for ages. We all know parents simplify their language with babies, but is it just simpler? Or is it actively enhanced to make things clearer? This study dives deep into that idea, and the results are super interesting. So the big idea scientists have explored is called hyperarticulation. It's the thought that parents, maybe without even realizing it, actually stretch out their vowels and make their sounds more distinct when talking to babies compared to when they talk to other adults. The idea is that this super clear speech helps babies learn the crucial sound differences that make up their language. Think of it like a parent saying mama with really exaggerated A sounds. Lots of past research has found that certain sounds, especially so-called point vowels like E, A, and U, do indeed sound more extreme or peripheral in baby talk. This led to the widespread belief that this hyperarticulation is a key feature of language learning input. But here is where it gets tricky. Not everyone agrees. Some studies haven't found this hyperarticulation consistently, and scientists started wondering if maybe this vowel space expansion wasn't some active teaching method, but just a side effect of other things parents do when talking to babies, like speaking slower, using shorter sentences, or even just smiling more. This new research wanted to test a very specific prediction of the hyperarticulation idea. If the goal is to help babies learn language, then parents should be exaggerating sounds that are different and important for distinguishing words, but sounds that are just variations of the same underlying sound shouldn't be exaggerated. Think about it this way. In English, the sounds in beat and beat are different vowels that create different words. Those are phonemically contrastive. But the slight difference in the N sound in tent versus the N sound in tent are allophonic. They're the same underlying N sound, just slightly changed because of the sound next to it. The hypothesis here is that parents would exaggerate the beat vs. Bit difference, but not necessarily the subtle variations in the N sound. So, to test this, researchers asked mothers to talk to their babies in two different ways. First, they talked to their infants, and then they talked to a confederate adult. They focused on specific vowel pairs. For phonemic contrasts, they looked at vowel tenseness, like the difference between say and set. For allophonic contrasts, they looked at vowel nasality, like in man versus man when it's said before a nasal sound. They recorded mothers speaking to infants of two different age groups. 4-month-olds who are really just starting to process sounds and 11-month-olds who are beginning to learn words. They set up a pretty neat recording session. Moms were left alone with their infants and a bunch of toys. They were asked to describe the toys to their babies. Then an experimenter came in, and the mom repeated the task, but this time talking to the adult stranger. This allowed them to collect both infants. Directed speech and adult. Directed speech from the same people. Now, how do you measure this hyperarticulation? They use sophisticated acoustic analysis to measure specific features of the vowels. They looked at how long the vowels were, their pitch, and something called formants. Formants are basically the resonant frequencies of the vocal tract, and they determined the distinct sound of a vowel. They also measured things like vowel bandwidth and pole amplitude differences for nasal vowels. It's a bit technical, but the main idea is they're getting precise measurements of the acoustic properties of these sounds. To check on the overall quality of the infant-directed speech, they measured the size of the vowel space using those point vowels, I, U, we talked about earlier. And guess what? Just like many other studies, they found that the vowel space was indeed larger in speech directed to infants compared to speech directed to adults. This finding suggests their recording setup was capturing the expected differences between the speech styles. But here is where the core hypothesis gets tested. When they looked at the sounds that are supposed to be phonemically important, like the tense versus lax vowels, they found something surprising. For the younger infants, there wasn't much evidence of increased separation between these sounds in baby talk. In fact, for the eye contrast, the sounds were actually less distinct in baby talk compared to adult talk. And when they used a more sophisticated measure that accounts for not just how far apart the sounds are, but also how much variation there is within each sound category, the results were even clearer. For baby talk to younger infants, the differences between these phonemically contrastive vowels actually got smaller, meaning they were less distinct in baby talk. This is the opposite of what the hyperarticulation theory would predict. Even when they looked at speech directed to the older 11-month-old infants, the picture wasn't clearer for hyperarticulation. For one of the phonemic vowel contrasts, E, there was a slight trend towards greater separation in baby talk, but for the other, I, it again showed a trend towards deterioration. meaning the sounds became less distinct. And what about those allophonic sounds? The ones that are just variations of the same underlying sound. As predicted by the hyperarticulation hypothesis, there was no consistent evidence of them becoming more distinct in baby talk. This part of the finding actually fits the theory. So, to sum up the results, while the overall vowel space might be bigger in baby talk, the specific differences between phonemically contrastive vowels, the ones that should theoretically benefit most from exaggeration, either stayed the same or actually became less distinct in baby talk, especially when you consider the variability within those sounds. The allophonic contrasts, as expected, didn't show exaggeration. What does this mean? The authors conclude that the strong version of the hyperarticulation hypothesis, which suggests that caregivers actively exaggerate all phonemically contrastive sounds to boost language acquisition, is likely false. It's not that all important sound contrasts are made clearer. They also point to other recent research that cast doubt on the hyperarticulation theory. For example, one study looked at mothers talking to twins, one with normal hearing and one with hearing impairment. The mother amplified her speech only to the child with normal hearing, which is counterintuitive if the goal is purely language acquisition. Another study showed that mothers expanded their vowel spaces only when the infant could hear them perfectly, suggesting the infant's actual ability to hear and respond plays a huge role. This research, along with others, is pushing for a more nuanced view of infant-directed speech. Instead of seeing it as a direct, hyper-enhanced teaching tool, it's likely shaped by a lot more factors. Things like speech rate, smiling, and the general positive emotional tone of talking to a baby might be the real drivers of some of these acoustic changes, like the expanded vowel space. One really interesting side finding here is about within-category variance. It seems that when parents talk to babies, there is actually more variation within each sound category, not less. This might seem like it would make things harder for babies to learn, but the researchers suggest that this variability, even if it seems counterintuitive, might actually help infants generalize and abstract sounds better over time. It is like exposing them to many different ways a sound can be, which ultimately helps them become more robust in their understanding. This increased variability is a really understudied area. While the study found it and suggests it might be important, much more research is needed to understand exactly how much it differs, why it happens, and what its true impact is on language learning. So while the idea of parents actively hyperarticulating all important sounds might be too simple infant, directed speech is still clearly crucial for language learning. This study suggests that the changes we hear in baby talk aren't necessarily about making every single phonemic contrast sharper. Instead, the bigger picture is likely more complex, involving a whole range of communicative behaviors and the dynamic interaction between parent and child. What I find really fascinating about this is how it challenges a long-held assumption. It reminds us that science is always evolving, and what we once thought was the whole story might just be a piece of a much bigger, more intricate puzzle. The idea that maybe the messiness of baby talk, the increased variability, is actually beneficial for learning is a really cool counterintuitive twist. It makes you rethink what clear communication even means in the context of early language development. It's also important to note the limitations. This study focused on American English mothers, so findings might differ in other languages. And while they did a great job controlling variables, the naturalness of the parent-child interaction means some factors can be perfectly controlled. Future research could certainly explore how other languages implement these sound changes. And delve deeper into the role of this increased variability. We need to understand if this variability is a bug or a feature, and how infants use it. So, what do you think about these findings? Does it change how you'll think about baby talk? Let me know in the comments below. If you enjoyed this dive into the science of how babies learn, give this video a like and subscribe to RUBIN'S Mind Lab for more fascinating research breakdowns. Thanks for watching, and I'll see you in the next one.